Hey, it's Mr. Sportelli here, and we are going to talk about some powers of 10 multiplication. And we see we have decimals right here, and our decimal multiplication with powers of 10 is going to look a little bit different than whole number or decimal times decimal multiplication. We do not need to use any type of strategy that we've learned for whole number multiplication. We don't need to put it in the area model, we do not need to put it in the standard algorithm or anything like that. There's a simple and easy way to do powers of 10 with multiplication, and I am going to show you. So let's start over here with this problem. We see 3 and 9/10 times 10 to the third. So first of all, this right here is an exponent. Now, we know that 10 to the third equals 10 times 10 times 10. So that's going to get us 1,000. So I would strongly suggest that if your student sees a number with an exponent, for them to rewrite the equation as a whole number. So we're going to rewrite it as 3.9 times 1,000. Now, with powers of 10 and multiplication and decimals, all we need to look at is, well, not all, but what we need to look at is our decimal point and how many zeros we have in our other product. When we look at how many zeros, that's going to let us know how many place values we are going to need to shift the decimal point. Now, you can't technically shift the decimal point, but that's the best way I know how to explain it. So we have 3 zeros, which means we are going to shift our place values to the decimal point 3 place values. So for every 0 that you have in your factor, you're going to shift 1 place value. So we know that when we when we multiply, we're going to shift to the right because our number is going to get larger. So we've got 3.9. We're going to take our decimal point, 1, 2, 3. Now in these two empty spaces here, we are going to go ahead and put zeros. Now, the decimal point has moved, and it's moved to after the 0 in the ones place. Now, since we have 3 numbers here, we're going to put a comma, and our product of 3.9 times 1,000 is going to be 3,900. Now the decimal point there at the end doesn't really matter. You can take it away if you want to, but it helps me because I know that that's where my decimal point is now. Okay? So let's take a look at a second problem. Now we have 4 and 651 thousandths, and we see that we are multiplying this by 100. Now, a way to write 100 in the exponent form would be 10 to the second, right? So, now, we see we have 2 zeros in 100, which means we are going to shift our decimal point 2 place values. Because if we remember, every 0 that we have in our factor is going to be a 1 place value that we shift. So, we're going to come here and we are going to look at our decimal point. We know that we're going to shift that decimal point to the right because we're multiplying. That means our number is going to get bigger. So, 2 zeros here, 2 place values. 1, 2. So I've got 465. My decimal point is now after my 5, which is again in the ones place. And then the 1 that was in the ones place is going to now be in the tenths place. So when we multiply 4 and 651 thousandths times 100, our product is going to become 465 and 1/10. Again, please remind your students that when they're multiplying by powers of 10 and a whole number or exponent, they don't need to put any multiplication in the standard algorithm or the area model. They can simply shift decimal places just like we did here.